Hi there, folks. Today we're looking at proving triangles similar. All right, and there's a couple of things that we want to consider here. One, a lot of this is going to seem like a throwback to proving triangles congruent. All right, we'll see some of the same types of theorems that we had. The big difference is when you think about similar figures, all the angles have to be congruent, and the sides all have to be proportional to the other figure. All right, and that's the difference really with congruent figures. All the sides would be congruent instead of proportional. All right, and so kind of looking at the same thing for triangles. With triangles, when we think about proving triangles congruent, we were looking for congruent angles and sometimes congruent sides. Now we're going to be looking for congruent angles and proportional sides. Okay, and so we'll utilize some of the same theorems, but the theorems will be slightly different in that we're looking for proportional sides, not congruent sides, okay? The other thing that kind of makes these special, and again, with similar figures have to have all congruent angles, okay? So the angles have to match up, but then all the sides have to match up proportionally, all right? But with triangles, I don't have to get all of the angles, and I don't have to get all of the sides. The idea behind a triangle is, remember, there's a special relationship between the sides of the angle and the sides of the opposite side. And so what happens if I were to compare two triangles that all had the same angles, where all the angles were congruent, the sides are automatically going to be proportional just with those angles being congruent because of that relationship between sides of the angle and the opposite side, okay? And so when we look at this first postulate, this kind of hinges on that idea, all right? And notice it's angle-angle-similarity. I said if all the angles were congruent, we automatically have proportional sides, okay? But we don't actually need all the angles, we only need two, and that's because of another theorem we have that said, hey, if two of the angles are congruent, the third one's automatically congruent. All right. And so, yeah, the idea behind the relationship is the three angles being congruent makes the opposite sides all proportional. But I really only need two of those angles. I only need to know that two of those angles are congruent to know that all three of them are congruent. And then that all of the sides are proportional. And so if I just have two angles that match up from two triangles that are congruent, then the two triangles are similar. Okay. They're automatically similar because the sides will automatically be proportional. All right. The next two theorems, these are a little bit more of a throwback to some of our other theorems when we looked at congruence. But side, angle, side, we had that same theorem for congruent triangles. Now we have it for similar triangles. And again, the only difference is I still want the angle in between, and it still has to be an angle in between the two sides. But I'm not looking for congruent sides, I'm looking for proportional sides, okay? So if two of the sides are proportional and the angle in between those sides is congruent, then the two triangles are similar, all right? So it's the same idea. I'm still looking for a congruent angle in between two sides, but I'm looking for the two sides that it's in between to be proportional to the other triangle. That shows similarity. If they were congruent, then it shows congruence to the other triangle. All right. Side is the same thing where we look at all three sides. And again, this goes back to that idea behind that relationship. If all three sides are proportional, well, then all three angles will automatically be congruent. Okay. It goes back to that relationship between sides of the angle and the opposite side. All right. But side, I just look at all three sides. When I was trying to show congruence, I needed all three sides to match up and be congruent. But now I just need all three sides to match up and give me the same ratio to be proportional. Okay. And so that's all we have here. Notice I don't have some of the other ones we had, like angle, side, angle, or some of those kind of things. And the reason for that is because, well, or angle, angle, side, I don't need that because I only need two angles. And so the idea between angle, side, angle, I don't need the side, I just need the two angles, okay? Between angle, angle, side, I don't need the side, I just need the two angles. And that's why we don't have those anymore, okay? So angle, angle, if two angles are congruent, the two triangles are proportional. Side, angle, side, congruent angle in between two proportional sides. The two triangles are similar. And then the side, if all three sides are proportional, then the triangles are similar. Okay. And so again, very similar to what we did with congruent triangles, but we're just changing that idea of looking at the sides for proportionality, not congruence. Okay. So if I look at these guys, determine which triangles are similar and justify your answer. So if I look at this one, notice no angles are actually given here. So I want to compare the sides on this one. And if I compare the sides here, I just start with the smallest side. So like in this one, I would start with like the 6. Well, that should correspond to the smallest side in the other triangle, which is the 9. And so if I kind of write that as a ratio, 6/9. And then I check the next one and say, hey, okay, the next one, let's see, that's an 8. And over here, it's going to be the 12. So I'm going to say 8/12. And then the next one, the last one here, the 10 and the 15. So 10/15. And here's the thing, to determine if these things are similar triangles, I just have to make sure each of these ratios is the same. That's what proportionality means. It means when I compare any of these, I get the same ratio. And so as I look at this one, this is a 2/3. This one is a 2/3. And this one is a 2/3. So when comparing the corresponding sides, I get the same ratio for each. That means all three sides are proportional. If any one of these sides didn't give me the same ratio, then the sides wouldn't be proportional. So since all of these are proportional, I can say that these are similar by side, side, side. Okay, so side, side, side similarity for this one. Okay. If I look at the next one, I have two corresponding sides that I can compare for proportionality. What I need then is I need at least the other side, or I need an angle in between those. And if you look, well, the angle in between those, these are vertical angles, so these angles are congruent. All right. So now I need to compare these sides. And again, I look at it in size order. It's always going to have to compare that way. And so when I look at this, the smallest side here should compare to the smallest side here. And so if I compare that, that's 2/6. And just make sure you compare them in the same order. So this one, I compare the 4 and the 12. Well, that's a 4/12. And as I reduce this guy gives me a 1/3. This guy also gives me a 1/3. And so what it's showing me is those two sides, as I look at them, giving the same ratio, the two sides are proportional. So I have two proportional sides with the angle in between being congruent. That's side, angle, side. Okay, so this is side, angle, side similarity. So these are similar by side, angle, side this time. If I look at this one, students start to get confused here because they start looking at these triangles and they see the 10 being congruent and they say, well, those aren't proportional. They might be congruent. Well, it depends on which side is given. And notice here, it's the side in between the angles, and here it's the side outside the angles, okay? So these are not necessarily congruent because we couldn't show them to be congruent by side, angle, side, or angle, side, angle, or anything like that. But we can look at similarity. And remember, with angles for similarity, I can do this with just two angles. And so if I look at this angle is congruent to this angle. So there's one pair of angles. And here's a second pair of angles. I don't need anything else for similar triangles. I can immediately just say, hey, these are similar by angle-angle-similarity. And that's it. If I look at the next one, once again, I only have one angle this time. So if I only have one angle, I need the two sides around that angle to be proportional. Okay. And so as I look at this one, I see the 6 and the 9. But be careful as I look at this one, this 7 is not the right side. I needed this side over here. And so as I start to look at the proportionality here, maybe I would compare like the 6 and the 8. But then the 9, I don't have anything to compare to. So I can't show proportionality for the two sides that I need here. And so this one, there's not enough information on this one. Okay. So I'm going to say not enough information. I'll just say not similar. Okay. I can't say that these are similar, so I'll assume they're not similar for now. But really, there's not enough information to prove or to show that these are similar. Okay. I didn't have the right set of sides to try to show proportionality. So taking a look at something like this guy, I'm given that AB is congruent to BC. Let me go ahead and mark that on my on the picture over here, AB and BC. So those are congruent. And then EF is congruent to FG. So these guys are congruent. And angle A is congruent to angle E. And so what I want to do is I want to prove that the triangles are similar. And so as I look at this thing, I'm going to start with my my given here. So let's see, statements and reasons. And I start with what's given. And the reason that it's given. Okay. And I already marked these things on the drawing, all right, on the figure that's up there. So now I got to think about what else I know. And as I kind of start to look at this thing, one of the things I look at is I say, okay, I have two sides, but I don't have the angle in between. So I can't go right to these things are similar. I need another piece of information here. Okay. And so as I look at this thing, the first thing I do is when I look at each of these triangles individually, I should notice that ABC is an isosceles triangle. I have two sides that are congruent, which means the opposite angles to those sides must also be congruent. Or when we think about isosceles triangles, we say, hey, the base angles of an isosceles triangle are congruent. And so right away, I have this thought here that angle A is congruent to angle C. All right. Likewise, if I look at the next triangle is also an isosceles triangle. So I could use the same logic to say, hey, that angle E and G have to be congruent. And it's for the same reason. And if you want to go back to that theorem that says, hey, the base angles of an isosceles triangle are congruent, we could say it that way. Or we could say, if two sides of a triangle are congruent, then the angles opposite those sides must also be congruent. And it goes back to that relationship. We could use either one of those here. Okay. So I'll kind of generically state that one. If the sides are congruent, the angles opposite those sides must also be congruent. Okay. And that's true for each of these triangles individually, but I still haven't related the two triangles together. What I've done is I've said, hey, A and C are congruent, and then separately I've said that E and G are congruent, okay? But that's still not enough to say the triangles are congruent because I haven't related the two. I've talked about each of those individually. What I need to say, I already have that A and E are congruent. What I need to say is that C and G are congruent, okay? And as I look at the picture here and I look at what I've labeled, I already have that those are congruent in terms of understanding that they are congruent, but I just have to justify that. So I have angle C is congruent to angle G. And so really to justify this, it's really my transitive property, but it's a kind of a long string of characters for my transitive property. If you look back up this previous one, C is congruent to A is congruent to E is congruent to G, therefore C is congruent to G, first thing to the last thing, all right? And so when I look at this, it's really just my transitive property. Okay, and now that I have that, well, I have everything I need. And notice the sides aren't really involved other than they helped me get the congruent angles that I needed. But I have a set of angles for each of these. I can say that the two triangles are similar. Triangle ABC is similar to triangle EFG. And I can say that just because I have a set of angles, two sets of angles here in each. So angle-angle-similarity, and that's it. So looking at this one, C is the midpoint of BD and has the given measures, the given measurements here, which are kind of given on the figure itself. And so let's start off our statements and reasons. And, if you're still struggling with proofs or at this point, just kind of look at this thing and kind of make a determination, just looking at the picture and start figuring things out. Like if C is the midpoint, you know that these are the same. All right. Now you know that this thing is a 6. Okay. And then right away, you know that these angles are vertical angles. They're going to be the same. And so as you start to look at this thing, you're probably already comparing these sides and saying, hey, 3/6 is a 1/2. And 6/12 is a 1/2. And so as you look at this thing, just gathering the information from the picture and running through it without actually writing down the proof, you basically have the proof here. You just now have to write this down and justify those things, okay? You can see that the angle in between these two sides is congruent, and you can see that the sides are proportional. We just have to express that in a logical way, okay? And so here we go. Let me erase this, and I'll remark these as we go. And so for this one, I'm going to start with the given. So C is the midpoint. And then we have the given measurements. I'm just going to write these out. I'm going to say AC equals 3. And I'm going to say that CD equals 6. And I'm going to say that CE equals 12. And all that was given. And then from here, we could be really, really picky about some of this stuff. like for the definition of the midpoint breaks things into two congruent pieces. So technically, I should say that BC is congruent to CD, and then I could say that BC is equal to CD because the definition of congruent, and then I could say that BC equals 6. But we're going to cut a little bit of that out. I'm just going to go right to saying for this one that BC equals CD, and we'll use the justification that that's the definition of the midpoint. Even though from a technical perspective, I should have an extra step in here. And then from here, I'm going to say then that BC equals 6. And really, that's my transitive property. If BC equals CD and CD equals 6, then BC equals 6. So that's my transitive property. You could maybe justify it by substitution as well. Okay. And then from here, the next step of this thing is really, I talked about that angle, so let me mark down what I've done so far. I said that, hey, okay, these are the same, so this is a 6. The next thing I want to talk about is that these angles are congruent, so I could easily say that because they're vertical angles. So let's see. So angle ACB is congruent to angle DCE. And that's because they're vertical angles, and we all know that vertical angles are congruent. And then from here, I just have to show that those sides are proportional. We kind of already know they are because we ran through it real quickly. But I just have to set up. I have to do what I was doing and say, hey, I'm just going to set up the ratio of these sides. So right here, I'm going to say that AC over DC equals essentially 3 over 6. But then I can also say, I can set up another ratio here. I can say that BC over CE equals 6 over 12, okay? And I'm allowed to do that because that's just what a ratio is, okay? So I'm going to justify it by saying the definition of a ratio. Definition of a ratio is just comparison of two things by division, okay? So I'm going to say the definition of a ratio here. And now, of course, I should simplify each of these ratios. That equals 1/2. That also equals 1/2, and that's just me doing a little bit of simplifying. Okay, I'm reducing the fractions. But now what happens here is as I look at these ratios, well, because these are the same, counting is pretty hard sometimes. Because these are the same, because this guy equals a 1/2 and this guy also equals a 1/2, I can now say that AC over DC equals BC over CE. Okay, and really that's just my transitive property again. And now basically what I have here is when I look at step 7, that's showing me that the sides are proportional. So sides AC and DC are proportional with sides BC and CE. I was about to write it as a fraction again, okay? And, you know, we can keep this step pretty simple and just say, hey, the sides are proportional. Look at the previous step, all right? And that's just the definition of proportional. Proportional means that the ratio given by those things is the same. Sorry, definition of proportional. And now that I have those sides are congruent, or sorry, those sides are proportional with the angle in between being congruent, I can now say that the triangles are similar. Okay, and they're similar by side angle side similarity. Okay, so again, and you know, depending on your teacher, they might be more or less picky. You might be able to cut out some of these steps. Maybe you didn't have to write the 3/6 and the 6 over 12. Maybe you could have gone right to writing the 1/2, all right, because that's simple enough. So again, it really kind of depends on how picky your teacher wants to be. But in terms of a general justification, we just want to show the ratio of each side is the same, making the sides proportional. That's how I incorporate that into my proof, okay?